Dear children, now to discuss different types of functions which we didn't study in class 11. First one is one function or injection. Another name is injection. One function or injection. A function f from a to b is said to be a one function or injection if different elements of A have different images in B. Different elements of A have different images in B. See this X arrow diagram. This is a function from set A to set B. You can see that A is mapped to 2, B is mapped to 1, C is mapped to 4, D is mapped to 5. So different elements of A are mapped to different elements in B, then this function is said to be one function. It means that suppose this is f of A and this is f of B. F of A and f of B are equal implies this should be equal, then only it become one function. So the conditions for one functions, thus f from A to B is a one function or injection, implies and implied by A not equal to B implies f of A is not equal to f of B for all A comma B element of A. That is, if these two elements are not equal, means these two images should be not equal. Said other ways, f of A equal to f of B implies A is equal to B for all A comma B element of capital A, the set A. It means that if the two images are equal, definitely the pre-images also should be equal. So these are the two conditions, and these are the conditions we are going to check for the injection or one cases for solving different questions. So one function I shall repeat. A function f from A to B is said to be a one function or injection if different elements of A have different images in B. Now the next is a many one function. A function f from A to B is said to be a many one function if two or more elements of set A have the same image in B. That is, actually draw the arrow diagram. Suppose these are the sets A and B. There is a function from f from A to B. Elements of A are 1, 2, 3, and here having A, B, two elements, and right? Otherwise that will be C also. Suppose one is mapped to B, 2 is mapped to A, suppose 3 is also mapped to B. You can see that the element 1 and 3 are mapped to the single element B, then the function is many one function. Of course, the constant function is also many one function. So this is a many one function. Now to discuss onto or surjection, onto function or surjection. A function f from A to B is said to be an onto function or surjective if every element of B is the f image of some element of A. It means that every element of B has a pre-image in A. Otherwise, every element of B appears to be an image of some element in A. So clearly, f of set A will be equal to set B. F of A, that is the range set will be set B itself. Now this is the one, there are two arrow diagrams. Let us discuss that. A and B be two sets. A is mapped to 2, B is mapped to 1, C is mapped to 5, D is mapped to 5. So every element of A has some pre-image in A. Every element of B has some pre-image in A. So the function is onto, but you can see that C and D are mapped to 5. So this is many one also. So this is an example for many one onto. So this is actually many one onto. And this is a many one onto. Let us discuss the next arrow diagram. A and B be two sets. One, the set B contains elements 1, 2, 4, 5. A is mapped to 2, B is mapped to 1, C is mapped to 4, D is mapped to 5. Every element of B has some pre-image in A, so it is onto. Also, different elements in A are mapped to different elements in B, so this is a 1, 1 also. So it is a 1, 1 onto, injective and surjective. So this is a 1, 1 onto. 1, 1 and onto. And that 1, 1 and onto function is known as, before that let me discuss into function. A function f from A to B is an into function if there exists an element in A having no pre-image in A. That is it. Suppose these are the two sets. Set A, set B. A function f from A to B is defined, and here it is 1, 2, 3. Here is a 2. So not 2. Let us it is some P, Q, R. 1 is mapped to Q. 2 is also mapped to Q. 3 is mapped to R. This is a function, of course. Every element of A has some image in B. So it is a function. But the element of P in B has no pre-image in A. So this is an into function. This is an example for into function. It's clear. This is the important one. Bijection. A function f from A to B is a bijection if it is 1, 1 as well as onto. It should be 1, 1 as well as onto. In other words, the function f from A to B is a bijection if it is first one 1, 1, that is f of x is equal to f of y implies x is equal to y for all x comma y element of A. And onto, that is for every element of B, there exists an every y element of B, there exists an x element of A such that f of x is equal to 1. And I shall repeat. A function f from A to B is a bijection if it is 1, 1 as well as onto. That is, f of x is equal to f of y implies x is equal to y for all x comma y element of A. This is the condition for 1, 1. Now onto, that is, for all y element of B, there exists some x element of A such that f of x is equal to y. This is the condition for onto. Why I have repeated this now? To prove a function is bijective, we have to take these two cases. So this is the example. Every element is mapped to different elements in B. So it is 1, 1, and every element of B has some pre-image in A. So it is onto. Let us discuss a question about a bijective function. Let A is equal to R minus singleton set 2 and B equal to R minus singleton set 1. A and B are defined in this way. 2 is excluded from R, that is A. 1 is excluded from R, and that is B. A function f is defined from A to B given by f of x is equal to x minus 1 by x minus 2. We have to show that f is bijective. How to? It's very simple. Bijective means the function is 1, 1 as well on. let us verify for 1 case first of all. So I am going to discuss 1. For that I am taking two elements from A. Let x1, x2 element of A. The conditions are for 1 case. Condition for 1 case to prove that f of x1 is equal to f of x2 implies we have to get x1 is equal to x2. F of x is x minus 1 by x minus 2. So f of x1 is x1 minus 1 by x1 minus 2. x1 minus 2. And that is equal to f of x2. F of x2 is x2 minus 1 by x2 minus 2. Let us simplify it, which implies that. Let us cross multiply it. You will get x1, x2, x1, x2 minus 2x1 minus 2x1 minus x2 plus 2 will be equal to, cross multiply, you will get x1, x2 minus x1 minus 2x2 plus 2. Now here this x1, x2 and x1, x2 get cancelled, plus 2 get cancelled. Let us bring that minus x1 to left hand side. So you will get minus 2x1 plus x1. So you will get this minus x1. So which implies that minus x1 is equal to, let us bring this minus x2 to right hand side. So minus 2x2 plus x2 is minus x2. Minus x2. So we are getting this is equal to x1 is equal to x2. So f of x1 is equal to f of x2 implies x1 equal to x2, which implies that f is 1. F is 1. Now to prove it is on to case. On to case. For that, let us assume that y element of B is what? The coordinate. And let y is equal to f of x. We are assuming that y element of B and y is equal to f of x. Now y is equal to f of x implies y is equal to x minus 1 by x minus 2. X minus 1 by x minus 2. Let us cross multiply it. So it is xy minus 2y is equal to x minus 1. Which implies that, let us bring this x to left hand side. So xy minus x is equal to, let us bring the 2y to right hand side. So it is 2y minus 1. So which implies that x into y minus 1 is equal to 2y minus 1 implies x is equal to 2y minus 1 by y minus 1. Now by taking y is equal to f of x, we obtain x is equal to 2y minus 1 by y minus 1. But I don't know whether this x belongs to A or not. In A, only 2 is excluded. If this happens to be 2, then x will not be an element of A. Let us verify it. That is the verification. If 2y minus 1 by y minus 1 is equal to 2. If it is happened, what will it be? Then 2i minus 1 will be equal to, by cross multiplying, it becomes 2i minus 2. By cancelling 2i and 2i, you will get minus 1 is equal to minus 2, which is not possible. Which is not possible. Why we got minus 1 is equal to y2? By assuming that 2y minus 1 by y minus 1 is equal to 2. So 2y minus 1 by y minus 1 is not equal to 2. It means that this x is not equal to 2. If x is not equal to 2, then the real number x will be an element of A. So we got, for a y element of B, the codomain, and x element of the domain. So the function is onto. We have already proved function is 1. So the function f from A to B is 1, 1 as well as onto, hence it is a bijection. Dear children, next we have to discuss about the composition of functions. We have discussed now different types of functions. We have discussed 1, 1 function, onto function, bijective function, and the functions already discussed in 11th class we have recorrected also.